you through the last video, welcome back. Today we're going to talk about battery banks.
So most boats have 2 battery banks, a start and house bank. We have 4 battery banks, and we're going to add another one.
Because apparently we're collecting batteries now.
We have a 24-volt house bank and a 12-volt house bank. Plus we have a 12-volt buffer bank that the alternator charges, and then we charge our lithium with a smart profile from that, but that's another video. But our 24-volt bank just powers the inverter, which is wasteful, and we don't like to use an inverter because it wastes a lot of energy, and you can get most of the stuff done with 12 volts anyway. It's more efficient. So we're going to separate the banks. I'm going to take the 24 volts, convert it to 12 volts, and then use that bank. That'll give us 1300 amp hour bank for hotel loads and a 400 amp hour lithium bank just for navigation loads. So I'll show you how we do that today. So this is where our batteries live under the settee, most of them, some of them. This is the 24 volt, 600 amp hour bank, and it's dedicated to feeding the inverter, that's it. So it's just for inverter loads, which we're gonna try not to use. So we're gonna separate that bank from this bank. This is the 12 volt, 400 amp hour bank, lithium bank. This is gonna feed just the navigation loads. As of now, this one's feeding all the 12 volt loads, navigation loads, creature comfort loads, everything. And this one's pretty much just wasted on this inverter. So we're gonna switch that up in this video. That's just our start bank. That is dedicated for only starting the generator and the engine. So everything can die, the engines will start and give us power back. So that's 3 banks right there. 12, 24, and 12 starting. I'll show you the other ones now.
We are headed to the other battery bank. It's our little collection of trinkets we started. Kind of cool. And into my favorite closet is where the batteries are.
So here is our buffer bank. These are 2 12 volt, 200 amp hour telecom batteries. They fit in there nice. That is, we have a dumb alternator. Our alternator charges them, and from them we use Victron DC-DC chargers that have a lithium profile to charge our batteries smartly. That's the workaround for people that have dumb alternators. So this is our setup here, pretty simple. 24 volt, 600 amp hour bank. It's feeding our inverter, which feeds 120 volt house loads, which we are going to use sparingly, if at all. We have the 12 volt, 400 amp hour bank that feeds everything on this boat that is direct current, and that's not good because we are wasting a lot of that amperage over in the 24 volt side. So we got to convert it back down to 12 volts and use it, and I'll show you how we're going to do that.
Now picture this. Somebody's in here getting their Richard Simmons on, full out sweating to the oldies. And if you get that reference, you're probably our age too. We all know apparently one light bulb just doesn't burn enough calories, so before long, all the TVs are on, all the lights are on, music's playing, and my little floating gym starts drawing real power. Then Eric comes in, turns the rest of the lights and TVs on, opens the fridge like cookies and ice cream are going to just magically appear. May as well check the freezer and forget to close the door too. Now the compressor is cooling the entire marina. Then eventually everybody crashes, but the battery bank doesn't, and we look like a floating Christmas tree. It just keeps paying for every bad decision all night long. That's the weakness in the current system. Comfort loads and critical systems are all drawing from the same bank. So if hotel loads quietly drain overnight, navigation essentials and systems can be dead by morning. The fix was to separate what matters from what doesn't. Critical loads stay on the 12 volt bank while hotel loads get moved back to the 24 volt bank. Then 2 Victron XS 1400 converters work together to bring it back to 12 volts, supplying up to 100 amps while a 100 amp hour battery buffer handles sudden demand spikes. So in practical terms, now the hotel side behaves like a 1300 amp hour 12 volt system.
So here's a little flow chart of the new system, how it's going to work. It's pretty basic. You see the battery bank, the Victrons, the bus bar. We've got a 100 amp hour lithium bank on the bus bar to absorb like compressor spikes or any kind of pumps that kick on. It'll absorb that load. And the Victron XS 1400s, they're chargers, but we have them set as power supplies. So this mess we got here, I'm taking all my 12 volt navigation electronics off of here, and I'm putting them onto the panel that I just installed. So I'll show you how to make the electrical connections. So while I'm in here, I'm also redoing all these suspect connectors. So you'll see that yellow one there, it's not heat shrink, and you can see the wire coming out the bottom is just copper wire. So that stuff's unacceptable for a boat, but everybody does it, and then their boat breaks down, and people always wonder why. So you always want to use the right stuff. It costs a little bit more money, but I've had pretty good luck with my repairs over the years. I've never really had nothing break because I spend the extra money and get tinned copper wire, heat shrink fittings, and everything you're supposed to do. So we'll show you how to make a proper fitting now. All right, so this is what tinned copper looks like. So it's copper, but it's got tin on it so it doesn't corrode, and that's what you want for boats. This is copper, not tinned. This is what goes bad eventually, and then your boat breaks down and you wonder why. So that's copper, so that's not good for boats, but it's there, so we'll use it. If you do got copper, you get some of this stuff here, this grease. This will it'll kind of stop it from corroding. You smother that on there, and that's supposed to stop the corrosion. There's the difference between a heat shrink and just a regular whatever, automotive or whatever, but you don't want to use these. You want to use these, and I'll show you why. So you want to take note of that little split right in there. You can see that little split. So when you crimp it, you want that split to be that way, not that way. And these things are pretty easy to color coded, so blue, yellow, red, different size fittings with different colors. So we're using blue, so I put it that way. Get your connector, slide it in, make sure it's all the way in. Take note of which way your split is. Pretty simple, match up your color. Boom. That's it. So if you use the wrong color, what will happen is you'll cut through this insulation, and then when you heat shrink it, you'll have bare metal exposed. So you always want to use the right color for the right terminal. Alright, so you get your torch and shrink it up. And it should be airtight. So if you're using the wrong connectors, like all these ones here, air can get in there, and it helps corrode it even more. So use the right connectors, the right fittings, and see it's glue in there. So it's another line of defense too. If this were to come off, the glue there would give you a little bit more before it would let go. So that's how you do a proper crimp, in my opinion. That's good pop.
Are those even hands? Your hands, I'm like, are those even hands? I look like gorilla hands.
So here's the finished product. We got 24 volt bank. There's the 24 volt bus bar. Comes with 2 breakers. You can see the wires are small because it's 24 volts. So that's one of the advantages of having 24 volts is you can use smaller wires. Had this been 12 volts, these wires would probably have to be double that size. So you get 2 breakers, one for each Victron. They feed through here into the next cabinet. And they feed into here, these 2 Victrons. The Victrons each have their own breaker. And you can see the wires are getting fatter. Now it's 12 volts here, so the wires are fatter. So they feed 2 breakers. Then it goes to a positive bus, which this battery's on. So there's another 100 amp hours, and it just absorbs shock loads. You can see you got the, just in case we're wrong, did a bad wiring job, we got the can of flame out. That's they're good to have around. And then lastly, here's the new panel we installed, 12 volt distribution panel. So we got lucky. Chris here at the marina let us pull a piece of teak off an old boat. Don't tell anybody I put the grain the wrong way, but Tara doesn't know that, so I don't know it either. But that's it. It's a finished product. So That's all the creature comfort loads that we don't care about. We can run them all night long and let them die. And then under here we have the 120 volt loads and also the navigation critical loads. Pretty soon I'm going to separate all them so we have the radar and everything different on different breakers. And that's pretty much it. Thanks for watching.